Part A, we do a few videos for hints for homework assignment number 2. Part 8.1, the first part, part 1, 2 questions. Question number 7 and number 11. Question number 7, for this question, I gave you a similar example before. In the notes, you can find that example. But here, the first thing I want to have you notice about it, do not get confused with that question. There is some significant difference between these two questions. If you just use the answer from that question, you will get wrong. Here, let me point out the main difference. R miss 1, R miss 2. Two miss rates. All right. R L1 miss rate 1 increased by 5% first. But in that example, our R1 is decreased by 5% first. So the order is different. Here, R1 increased by 5% first, R2 decreased by 5% next. In that previous example, R1 decreased first, that's R1, R2 increased next. Okay? So there our analysis is based on this assumption. Then we get that answer. But here, the answer could be different. All right. So here, let me just use the main formula to do the analysis. The average memory access time for two-level caches, the general formula, T1 hit time plus R1 miss. Here, I just write a simple way, okay, times hit time 2 plus R2. All right, multiply the penalty 2. All right, so now this time increase by 5%. So the next time, you add 5%. All right. Then here, you need to multiply 1 minus 5%. All right. When you do this modification, the second time, you compare it with the first time. Okay. All right. So if you multiply out, so you have 3 terms, right? The first term, the same as before. The second term, R1 T hit 2, third term 1 plus 5%, 1 minus 5%, R1 R2 P2. Okay, all right. So when you do the comparison, the first time equal, right? The second time, if you compare with the older one, it's greater than the older one, right? 1 plus 5%. Then, if you compare with the older one, older version, the term, it is less than old. Now, look at this. Second term greater than, third term less than. Which one bigger, which one smaller? How do you know it? How do you know which one bigger, which one smaller, right? The point is here. Okay? If you notice this critical point, then you can answer the question correctly. Okay? All right, so that's my hint for question number 7. Next one, number 11. So here, the reason, so that student asked me a question. So here I think there are several basic things you need to know. You need to connect those basic information pieces. Then you can solve the problem easily. Yeah. So let me point those pieces out. Yeah. All right. So the hint here. Okay. All right. Suppose that a unified cache. So you know here it's a unified cache. Okay. Yeah. So this gives us the information. There are two parts. So the unified cache, we need to process. We need to work on data, two parts, instruction part and the data part, right? Data part is on top of instruction, okay? Yeah. On top of. So that means every time you need to load the instruction first, but some of the instructions may require data access. Okay. May require data access. Okay. So that whole thing we describe using a diagram in this way. Okay. So when you run a program, you need to load all the instructions, right? Now, all the instructions, each one loaded once into the memory, cache, CPU. Yeah. So this is your instruction part. After that, you need some of the instructions you need to have the second time memory access for data part. Yeah. So that's the second time, so data access here. Okay. When you combine together, so that's the memory access. All right. So here, that's the background. So I just set up the environment. Then I can talk about the data here. All right. It is known that 25% memory references, 25% memory references, okay? Memory references, not instruction. That's important. It's memory references. That corresponds to this part. 25%, this part, data transfer. Yeah. Not, so the first point, not 25% of the instructions. That's different, okay? Of instructions. All right, so when you see that, now you need to modify your diagram in this way. Yeah. For convenience, in that situation, for convenience, yeah, you'd better set the whole line segment, 100 memory accesses, right? Here I said for convenience, because this way it is most convenient. For convenience, okay? Yeah. Yeah, convenience. All right, okay. All right, so then 25% data transfers. That's 25 instruction data transfer, right? Remaining 75% instruction. Okay, yeah. Now you know the ratio, right? 75, whenever you have 75 instructions, you need to load data 25 times. One third, okay? That ratio, so you get an idea, that ratio. Now, with this, we can calculate the miss rate. Miss rate formula. Okay, all right. The general formula, number of misses over number of memory accesses Okay, all right. So now, okay, all right. Misses per 1,000 instructions 30. Okay, misses per 1,000 instructions. We are given 1,000 instructions. Okay, 1,000 instructions. We have 60 misses. All right, so here you know the numerator 60, right? What is the denominator? Definitely you cannot put 1,000, right? Because 1,000 is 1,000 instructions. You need to convert it to certain number of memory accesses, okay? When you have 1,000 instructions, you need 1/3 extra data accesses, okay? All right, so here, when you have 1,000 instructions, you need to have 1/3, yeah, because 25 from 75, 1/3, right? 1/3 of data accesses. Adding together, that's the total number of memory accesses. Look at that. Look at that kind of, pieces you need to connect. Okay, you need to connect the information pieces in this way. Then you can find the answer. Okay, all right, so hope you understand, the diagram, the picture, why we draw the diagram in this way and that way, right? The definition of the miss rate. So after you understand all these things, you can solve this question correctly. Yeah. All right, so let me stop here for our part 1. Yeah.